Now in another problem, which is relevant to this one, it is problem 6.4 and part A of it. And part A of 6.4 problem, it says that find the second order correction to the energy of this situation, that what will be that correction. So we will find now this one En2. Now here we are having the equation. First we will calculate the numerator and then the denominator and divide them. So here the first one, let me do calculate psi m0 h prime psi n0. Keep in mind this thing, that this symbol, the vertical line, if you insert or not, it makes no difference. So sometime I do and sometime I just leave it. So it will be equal, write this thing in integral form. So 2 alpha over a will come in, and then from 0 to a, and put the values in this one, it will be sine m pi x over a, then the delta function delta x minus a over 2, and then sine n pi x over a and dx. So this is, we have already done this practice, so I just wrote it quickly. And now you apply the delta function. So the delta function will be 2 alpha over a. When x is a by 2, so it will become m pi by 2. So sine m pi by 2. And this one will become sine n pi by 2. Sine m pi by 2 and sine n pi by 2. And now we can put some restrictions on this one, that this will be equal to if, for example, let's start here. If m is even, then this value will go to 0. If n is even, it will go to 0. If any of them is even, it will be 0. So when the value will exist when both m and n will be odd, otherwise the values will be 0. So I can write that this is equal to 2 alpha over a if both m and n are odd and 0 otherwise. Means all the situation I have written combinedly is otherwise. It will be 0 if one of them is even and so on. Now I can put this thing back into this equation, the second order correction, and this will be equal by keeping in mind that em0 will be m square pi square h bar square 2ma square, and m0 will be just m index replacement. So I can write that the second order correction to the energy En2 is equal to summation on m not equal to n, and both are supposed to be odd, and 2 alpha over a, and this is equal to, means the second order correction, this one is squared, so I have to square this one because I just found this value and it is supposed to be squared. And then I can write 1 over e n0 minus e m0 for odd m and n. So now I can write that this value comes out to be 0 if n is even M is not supposed to be equal to n, so I can write that, put the values here first. It will be n square pi square h bar square 2ma square. So 2m, it will go up. The 2ma square will go up and divide by pi square h bar square, while the indices n and m I will separate out. So I can write that this is 2m and then 2 alpha over pi h bar squared, because the a squared here will cancel with the a squared here, and I will have just 2 alpha over pi h bar from this one comes here, so I have written them in a square form. Then summation on m not equal to n, and both are odd, 1 over n square minus m square. Now n is not equal to m, and both n and m are odd. So this is the second order correction to the energy. The first order correction we have already found that the first order correction is this one. Now the n odd will give the value, n even is gone. So m even is gone, m odd will give the value. So 2 alpha over a, the first order correction, means this energy will be added with this one, and plus this will be the next term. And you can see here that the next term is even less than that one by looking to the value of h bar. So this is the second order correction to the energy. Now we will solve problem 6.3, and in problem 6.3 let me just say the statement. Two identical bosons are placed in an infinite square well. They interact weakly with one another via the potential, and the potential is given by V of x1, x2 is equal to minus a V naught delta x1 minus x2. This is the potential with which they do interact. Now the question here, V naught is a constant with the dimensions of energy. As here is potential, so this is constant, this is having the dimensions of potential or energy, this is delta function. The dimensions of delta function are 1 over of the domain of it. Like when it is delta x, then its dimensions are 1 over x. And a is the width of the well, so it becomes dimensionless. Like this is length, a is the length, 1 over a means, so length will cancel and you will have potential. Now the first question, which is part A. First, ignoring the interaction between the particles, find the ground state and the first excited state, both the wave functions and the associated energies. In the first, we will ignore any interaction between these bosons, and we will find the ground state energy and the first excited state energy. While in the B part, use first order perturbation theory to estimate the effect of the particle-particle interaction on the energies of the ground state and the first order excited state. Like when we will consider a little bit perturbation in this system, and we assume that now the two bosons are interacting with each other, then how the energies will be modified. So the very first one, this is, we will use the same psi n. Psi n is 2 over a, and sine n pi x over a The same wave function we will utilize with energy En equals n square pi square h bar square over 2ma squared. This is the wave function and the energy associated with it. And now what about the ground state? First we will calculate the ground state. Means it is part A, and we calculate the ground state and then the first excited state. So the ground state will be, now for the bosons in chapter 5 we have written the two interacting and non-interacting bosons. We have written their combination of wave functions. So psi 1 0 of x1 and x2 is equal to psi 1 means the one boson wave function, psi 2 of x2. They are overlapping wave functions. And what this will be, just put the values of psi 1 and psi 2 here. And this will give you that this is equal 2 over a square root, and square root will multiply, so you will get only 2 over a, and sine pi x1 over a sine pi x2 over a. So this is the ground state wave function. And what about the first excited state wave function? The first excited state. For the first excited state, I can write psi 2 0 is equal psi 2 0 of x1 and x2. We are having two bosons, and this is equal to 1 over square root 2. And you remember this situation as well, which we have written for the fermions and bosons. Psi 1 x1, psi 2 x2, and plus here for psi 2 x1, psi 1 x2. This with the plus symbol. I hope you remember that for the bosons we are having it like this, and now you will have to just put their values. And what it will be? It will be again psi 1 and psi 2 here, so 2 will be multiplied. Psi 2, psi 1 here, 2 will be multiplied. So here 2 over a will come, and that 2 over a will simplify with this square root 2, so I can write under root 2 in a. So this is equal to square root 2 and divide by a, and then I can write sine pi x1 over 2 and sine pi x2 over 2. Like psi 1 x1, psi 2 x2, and plus sine. Okay, another thing that we will have to keep here in mind, and that is that here this is 1, so we are having 1 here, but here this one is 2, psi 2, so it is unequal to 2, and I will have to put 2 here as well. So 2 pi over this one is a, not 2. This is a and this is a. So 2 pi x2 over a, and plus sine 2 pi x1 over a and sine pi x2 over a. This is the excited state wave function. I hope you understood this point, that here when it is psi 2 psi n, so n is 2 here, n is 1 here. And what about the energies? This was let me write the energy for this one. The energy for this one is E10, the ground state energy, which is the two bosons are there, so 2 times E1, and I can write that this is E1. I have already written pi square h bar square over 2ma square. So when 2 is multiplied, 2 will cancel, and I can write that this is pi square h bar square over ma square ma squared. And what about the energy here? Now the energy here is E20, means the first excited state energy, and it is equal to the energy of 1 plus the energy of 2. And when n is equal to 1, so you will get pi square h bar square over 2ma square. When n is 2 here, so it will become 4 pi square h bar square. So I am having pi square h bar square for n equal to 1 is 2ma square, plus when n is 2, so it will become 4 pi square h bar square over 2ma squared. Now the denominator is the same, so I can just add them up, and I can write that 5 by 2 pi square h bar square over ma square is the first excited state energy. And now we are set to go to part B. And in part B, when we consider their weak interaction, it will be a kind of perturbation. So how these energies, these wave functions and these energies are modified for the bosons. So the very first one, when this is the first order correction, which is E11. Here it is E10, means the ground state. 0 means the ground state are the unperturbed. Here E20. The first E1 is the ground state, E2 is the first excited state, but this is the unperturbed. There is no perturbation. When in part B we will consider perturbation, so to the E1, the ground state energy, the first order correction to the energy, and E1 will be equal to psi10 h prime psi10. And now this thing is equal. Put the value, means psi10, I know the values of this one, psi10 I can write from here. Then it will be h prime. H prime is already this potential. This is the h prime. So minus a times v naught, and then delta will come inside the integral and the two wave functions. So I can write it like this, that minus a v naught, it will come outside. Then 2 over a will also come outside, because the 2 over a from this one, 2 over a and 2 over a, and then means psi10. This is psi10. 2 over a from this one and 2 over a from this one. So it will become 2 over a squared. And then I will write from 0 to a, and another integral from 0 to a, because there is x1 and x2, and this will be sine square this one. So sine square pi x1 over a and sine square pi x2 over a. This is the one that I have written for this one. And in the next one means like psi 1 0, so 1 sine pi x1 over a, and then here will be sine pi x1 over a conjugate, and the non-conjugate will multiply and we will get sine square of this. Similarly, the other one, this one will also become squared, and then the delta potential, which is delta x1 minus x2 and dx1 dx2.